Homework 3.8, Rational Functions, Video 8. Homework due Wednesday, May 27th, 2020 at 11:59 p.m. The following question, and in fact the remaining videos, will all be associated with questions 17 through 21. It's time to put it all together. It's time to graph these things manually. Now, I know there is technology available, I've been showing it to you, that will just throw a graph up there and you can look at it and pick information off of it. But remember in your test that your answers need to be supported by your work. So just giving me answers on the test won't cut it. So you need to be able to show me all your work. Now if you use technology to check your work, I'm okay with that, just not during a test. All right. So this is based on how questions 17 through 21 will look, where they give you a rational function and ask you to do a lot of things with it. Symmetries, odd function or even function, so y-axis symmetry or origin symmetry. Y-intercept and x-intercept, no surprise there. Vertical and horizontal asymptotes, not really a surprise. Extra points, and I'll talk about what that means in a moment, and then put it all together to make a graph. So let's do it. Let's start with the symmetry. And remember, for symmetry, you have to check to see if the function is even, which means putting in a negative gives the same answer as putting in a positive, or odd, meaning putting in a negative gives the opposite of putting in a positive. But both of these say what happens when you put in a negative. So let's put in a negative. And by the way, we can't just look at powers, that only works for polynomials. This is not a polynomial. Let's put in a negative for each x, and let's be efficient about it. If I change the x on top to negative, it says 2 times negative x, which is negative 2x. And on the bottom, I would get negative x minus 5. Now, before you instantly say this is not the original function, because we're dealing with a fraction and negatives, you need to be a little flexible when moving negatives around. Now, what do I mean by that? If you ever have a negative in a fraction, you can factor it out of the top and put it in front or put it back on the bottom. So for example, although this doesn't look like the original function, I can pull the negative off the top, put it in front. Still doesn't look like the original function. Excuse me, this negative is still down here. It's like something's wrong. That doesn't look like that. But I can take that negative and give it to the bottom. And if I give it to the bottom, it would distribute. And it would turn the x positive, but it would turn the 5 positive also. Do any of these look like the original? No. I think we can safely say that this is not even. None of these are the original. But is it odd? Are any of these the opposite of the original? Not really, because think about it. If it were the opposite of the original would have a negative in front of that. And there's no way I'm going to make this look like one of those. If I put the negative on top, then the top matches but not the bottom, and no other location is going to work. Most of these it'll be pretty obvious if it's odd or even, but this one's not. And it's neither. So no symmetries. None. That's a good default answer, but there are some where it is either y-axis symmetry because it's even or origin symmetry because it's odd. I'll leave that up there for the next example after this video. I've got 4 examples lined up. I may not do all of them, but after this first video, if you feel comfortable, consider the last 3 videos optional. But I chose the ones I chose for reasons, so hopefully you'll watch all of them. Y-intercept, well that's an old story. So the y-intercept, you let x equal 0. Well, on the top 2 times 0 is 0, and on the bottom 0 minus 5 is negative 5. So we have a y-intercept at 0. That should be an x-intercept also. For an x-intercept, we have to solve the function equal to 0. And let's do that over here just briefly. If we put 2x over x minus 5 equal to 0, well, if you're solving an equation with fractions, a pretty good move is to multiply both sides by the denominator, because that kills the fraction. But it does even more here. Not only does it kill the fraction, but the other side stays 0. And now it's easy to solve. oh, our x-intercept and our only x-intercept is at 0. So it's the same place as the y-intercept. So let me clean this up. Our y-intercept was at y equals 0. Our x-intercept is also at x equals 0. The asymptotes will be pretty easy to determine. For the vertical asymptote, you look in the denominator and you ask yourself what makes it 0. 5. But does that also make the top equal 0? No. Since x equals 5 makes the bottom 0 but not the top, that is a vertical asymptote. For the horizontal asymptote, you look at the ratio of leading coefficients. Excuse me, you compare degrees first. The degrees match, they're both 1. And when they match, you look at the ratio of leading coefficients. The leading coefficient on the top is 2, on the bottom it's an implied 1. So the horizontal asymptote is y equals 2 over 1, but why did I write that when I could just write 2? Now before we get to the extra points, let's sketch what we know. We know that there is both an x and a y-intercept at 0. And more importantly, those are the only intercepts. We know there's a vertical asymptote at x equals 5. So let's go over here to 5 and drop a vertical asymptote. And we know there's a horizontal asymptote at y equals 2. So let's go to y equals 2 and put a horizontal asymptote. Now, this does not look like enough evidence to locate this graph. It is, but let's not get into why. You find a graph by locating evidence, aka points. I need more dots. Now in the homework, when it gets to this, it will tell you what numbers to put into the function, and it'll ask you what are their y values, and that will help you make enough dots to find the graph. But if you're doing it on your own without somebody guiding you, here's the rule for looking for extra points. There are two x values that we already know about. We know about x equals 0, and we know about x equals 5. To find more evidence, you want to pick x values between and around these. Remember when we partitioned the number line and we picked test points? It's kind of the same thing here. We need a point to the left of 0, we need a point between 0 and 5, we need one to the right of 5. So I'm going to make a table here by picking some points around the x's that I already know about. For example, I want to try something to the left of 0. I could try -1, but let's go a little further and say -2. Again, the homework will tell you what numbers to put in. I need something between 0 and 5. Let's pick 3. Why not? And I need something greater than 5. Let's pick 7. I'm just picking numbers at random here. This may be enough information. This may give us enough evidence. The problem with this is that you have a rational function which will usually end up being a fraction. Deal with it. Think of it as a decimal if it helps when you graph it. For example, if I put -2 in this, the top will be 2 times -2, which is -4. And the bottom will be -2 minus 5, which is -7. Well, I can't reduce -4 over 7, but I can make it positive because negative divided by negative is positive. And for graphing purposes, it would be nice to know what this equals. It's about, let's see, 1, 4, 2, about 0.57. You can put it in a calculator, but it's a little more than a half, which means I can go back 2 and up just a little bit more than a half. So we'll put it down right there. It's not a lot to go on, but it's a start. If we put in 3, let's make some space here. If we put in 3, we would get 2 times 3, which is 6 on the top. But on the bottom, we would get 3 minus 5, which is -2. 6 divided by -2 is -3. Okay, so when I go over 3, I go down -3. So about here. Okay, these 3 dots kind of make me want to connect them and work around these asymptotes. So I think I have enough evidence over here. If not, I could always go fish out some more dots. But I have no evidence on the right side of 5. I actually do. I'll explain what I mean in a minute. So let's pick something on the right side of 5. I think I said 7. If I put 7 on top, 2 times 7 is 14. And if I put 7 on the bottom, 7 minus 5 is 2. 14 divided by 2 is 7. Hey, I put in 7, got out 7. So over 7 and up 1, 2, 3, 4, 5, 6, 7. Dot here. That's not much to go on, but it's enough. Because I know that I need a branch over here, and it's either above or below the horizontal asymptote, and this point is enough evidence to say it's above. Now, I can put in some more dots to confirm that it's going to be up here, and frankly, I'm zoomed in too close. I would have to zoom out to see it better. And there's the graph, or at least a good enough graph that we can draw by hand. In the homework, the graph is a multiple choice question, so you just have to pick the one with the correct features. Before I get to Desmos and graph this to show you how close I was, I want to point out that I really didn't need this extra evidence to know that the branch was up here. Because there is evidence over here by not what I see, but what I don't see. The branch never had a chance of being down here. Because if it did, it would have to have an x-intercept, and there wasn't one. It's a dirty trick, but it works. Just for kicks and giggles, let's check out Desmos. Okay. So let's get rid of this. Well, let's just clean it up. The top was just 2x, so let's make that 2x. And the bottom was x minus 5. So x minus 5. And our graph looked like that. We said the horizontal asymptote was at y equals 2. So let's draw that. Yep. And we said the vertical asymptote was at x equals 5. That looks good. We could also check that we have an intercept here. And honestly, we could also check the points. -2, comma, -2's here because it zoomed out. So negative, well, anyway, it has the right asymptotes, the right intercept, and the branches are in the right place. So we did good. We'll take a look at another more complicated example in the next video.